Part 4 of the notes focuses on factoring when a is equal to 1. A is the number that is in front of the x squared term. We're going to be taking a look at trinomials. So trinomials means that there are 3 terms in the expression. And in order to factor, we turn these 3 terms that look like ax squared plus bx plus c, and we're going to write them as a product of binomials. We saw something like this when we took a look at intercept form when graphing. That looked like a times x minus p times x minus q. Essentially what we're doing is we're converting from one form to another, from standard form to intercept form. Let's start with number 9. Number 9, A is 1, B is 1, and C is -6. Now, there are 2 methods that I can do when trying to factor. There's guess and check, and there's also something called the box method. The box method is more so when A does not equal 1. I'll introduce it to you in this video, maybe do 2 or 3 with that. But for the rest, I'll use the guess and check method, just because it's so much easier when A is 1. Okay? Starting with number 9, guess and check, what we do is we want to see the factors of C, and we ask ourselves what factors of C would give us the middle term, so B. The factors of 6 are 1 and 6, 2 and 3. Now there's a negative sign here, meaning that when you multiply these numbers together, one of them is going to be positive and one of them is going to be negative. Using different signs, I want to know which pair could I use to get a positive 1? Well, if I have a positive 3 and a -2, that would give me a positive 1. So -2 and +3 is what I want to do. To write them as binomials, I would do x minus 2 and x plus 3. If I wanted to double check and make sure it works, we could do something called foiling, first outside, inside, last. You did this in Algebra 1. So if I multiply it out, x times x is x squared, plus 3x minus 2x is plus 1x, and then -2 times +3 gives me that -6, so it does in fact work. If I wanted to use box method, what we would do is draw a box and cut it into 4 smaller boxes. The first term goes in the first box, the last term goes in the last box, so I need to bring that negative sign with the 6. Then we would multiply these 2 together, so -6x squared, and list out the terms. 1 and 6, 2 and 3. Now, x squared also needs to be included when writing our factors. So x times x gives me x squared. That's why we have an x here and an x here, by the way. This negative sign means I need to use different signs. So one will be positive, one will be negative. And it needs to give us the middle term. So you see some similar ideas here with guess and check and box method. So that gives me my positive 1x. It doesn't matter if I put the 3x or the 2x in opposite boxes. We're going to end up with the same answer. So the last thing after I plug in my 2 terms, the 3x and the -2x, is I find the greatest common factor of both vertical pairs and both horizontal pairs. Starting with the 3x and the -6, the GCF here would be a +3. We're always going to keep the sign of the outermost box, so +3 here. The GCF between x squared and negative 2x is 1x. The GCF between x squared and 3x is 1x. And the GCF between negative 2x and negative 6 would be a negative 2. So both of them were divisible by 2, and we're keeping the sign of the outermost box. The answer is what we wrote. X plus 3, x plus 3, x minus 2, x minus 2. Let's take a look at number 10. Number 10, I'm going to show you using guess and check first. So the factors of 28 are 1 and 28, 2 and 14. Then we have 4 and 7. Okay? Now we have to ask ourselves, using different signs, because it's negative, what pair could give me negative 12x? So that won't work. 2 and 14 would, though. I would have to make the 14 be negative and the 2 be positive if I'd like to get a negative 12. Meaning that the answer would be x plus 2, x minus 14. Remember, I could check my answer by foiling if I wanted to. I'll show you box method one more time. Again, I'm going to use this idea later on when a is not equal to 1, but it's good to be introduced to it now. The first term goes in the first box. The last term goes in the last box. We multiply these two together, so that gives me a negative 28x squared. List out the factors. That would be 1x and 28x, 2x, 14x, 4x, and 7x. Because I have a negative sign, that means I need to use different signs, one positive, one negative. So that would be a negative 14 and a positive 12. Or 2 to get a negative 12x. Plug in the 2x in one of the boxes and the negative 14x in one of the boxes. Then find the GCFs. So the GCF between 2x and negative 28 is a positive 2 because there's a positive on the outermost box. The GCF between the x squared and the negative 14x is 1x. The GCF here between x squared and 2x is 1x, and the GCF here between negative 14x and negative 28 is a negative 14 because there's a negative on the outermost box. The final answer is x minus 14 and x plus 2. It's worth mentioning that if this were a positive, that means we'd have to use same signs, not different signs. Number 11, listing out the factors of 48. I know there's 1 and 48, 2 and 24, 3 and 16, 4 and 12, and then 6 and 8. That should be all of them. Now this is negative, so I have to use different signs to get a negative 2. That won't work, that won't work, that won't work, that won't work either, so I'm left with the 6 and the 8. If I want a negative 2, the 8 has to be negative, and the 6 would have to be positive. That gives me negative 2. So that means the answer is x plus 6 times x minus 8. For number 12, we have x squared plus 14x plus 48. So that plus sign means I have to use same signs. Okay, so negative means different signs. Positive means same signs. So either a plus plus or a minus minus. Different signs is one will be plus, one will be minus. The factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. I can just write the 1 since I already have them listed. That would give me a 14x using same signs. That won't work, that won't work. Using the same signs, I'd have to use the 6 and the 8 once again. Now if I want a positive 14, it would have to be plus and plus to give me a positive 14. So the answer here is x plus 6, x plus 8. Hopefully we're starting to pick up on this a little bit. Let's move on to number 14. Now number 14 is different, so I'm going to star that. It's different because now a is not positive 1, it's a negative 1. So I'm going to have to pull out a GCF to make this a positive 1, and that GCF would be negative 1. If you pull out a negative 1, then you have to divide each term by negative 1, essentially changing the sign. So this becomes a positive v squared, this becomes a negative 2v, and that becomes a positive 1. This is what I can factor. The terms, or the factors of 1 would be 1 and 1. Using the same sign, because it's positive, am I able to get a negative 2? Yes, both of them would have to be negative. So I have v minus 1 and v minus 1. Now, when you write your final answer, you cannot forget to write your GCF out front. Okay, a lot of people do that. It doesn't magically disappear. We need to show it. So the GCF is negative 1, and I multiply these two together. I want you to notice, though, these binomials are the same. So if I have something times itself, I could rewrite that as something squared. Okay, again, these binomials, it was something multiplied by itself, so I can rewrite that as something squared. Number 15, the factors of 18 would be 1 and 18, 2 and 9, 3 and 6. I have to use a different sign because it's negative. Using different signs, what would give me a positive 3? Well, that would be a positive 6 and a negative 3. So the answer here is x minus 3, x plus 6. Number 16, factors of 3 are just 1 and 3. It's positive, so I have to use same signs. And I want to get a positive 2. I mean, using different signs, I could have a positive 3 and a negative 2, but that's not same signs. So that doesn't work. Positive 1 and positive 3 is a positive 4. Negative 1, negative 3 is a negative 4. So it doesn't work. And they won't always work out. So when that happens, just put not factorable. Number 17, A is not 1. So I need to see, is there a GCF that I can pull out? The answer is yes, there is. The GCF here, if I look at all three terms, everything's divisible by 2. So that gives me 2 times, and then in parentheses, we're going to write what remains. Remember, divide each term by 2. That would give me p squared minus 4p plus 4. Now, what's in parentheses, that is what we factor. Okay? This is our focus now. Right? 1 and 4, 2 and 2 are the factors of 4. Using same signs, I want to get a negative 4. So that would be a negative 2 and a negative 2. Meaning that my answer is, don't forget the GCF, so 2 times p minus 2 times p minus 2. But, and this is similar to number 14, if I have something times itself, I can rewrite it as something being squared.